Okay, hello everyone. We're Team Paramount, and during our time at AI Camp, we created a hate speech detector. So our mission was to stop online harassment and combat hate speech in social media and other big platforms. We created a hate speech detector to help mitigate the uncontrolled spread of hate speech online. Our team created a machine learning model that can essentially assess whether a text has hate speech or not. You would essentially input any text in the model, and it would classify it as having hate speech, offensive language, or neither of those things. Like mentioned in our mission, as content grows, we believe it is imperative to have the resources to supervise them. The tools to help control the amount of hate speech online is necessary in our day and age. So moving on from this preview of our product, we can go ahead and actually try out our actual model demo. We can test out different classifications of text. So as Annie put in here just now, she put in something that would be classified as neither offensive or hate speech. And right now she's going to put in something that would be classified as offensive language, but not particularly hate speech. So essentially the model will assess the inputted language and print out what it would predict the text to be. So it would say that this is offensive language. So we can actually try to make this output hate speech, but for the sake of the presentation, we're not going to demo that because we don't want to present any strong slurs or explicit language to everyone. But like previously mentioned, if you want to try it out yourself once the website is published, you can. But from here on, we're going to move on to the actual presentation.
So we'll talk about the process now. So first, we gathered the Twitter data from a GitHub. And then to pre-process, we created a function that would do everything for us with read out submethods. And then we also got rid of unnecessary words in the data. And then once we completed that function, we called it onto the data and then used count vectorizer to vectorize the data as well.
So this was a pipeline of the process of our project. So first we prepared the data by loading it and then pre-processing it like Annie described. And then we extracted the features. And then we built and trained the model by trying out a few different machine learning models and evaluating them to see which one would perform the best. And then we attach it to the website to take in different inputs and then see what the model would output. So we tried 3 different classification models, and the first one we tried was logistic regression, and we used an sklearn linear model, and it reached an accuracy of around 90.6%. So this ended up being our most accurate model because it wasn't too overfitted, so we used this one for the website. But we also tried out a support vector machine learning model, and we used a linear kernel SVM, and it reached an accuracy of around 89.5%.
So the third model we used was the deep learning neural network. As you can see here, we have 4 layers. The first 4 consisting of the ReLU activation function, and the final one using the softmax. And as you can see here, the training accuracy was 99%, and the testing accuracy was 87. So our original prototype had a lot of overfitting, so we added a dropout and early stop in order to mitigate for that. So next, the evaluation for these 2 models, logistic regression and SVM. The labels here, 0, 1, and 2. So 0 is hate speech, 1 being the offensive language, and 2 being neither. As you can see here, both models did the best at predicting the offensive language, but did the worst at predicting for the hate speech.
Can you pause for 1 second? So here, is it like when I see the accuracy that high, is it because most of the time like the labels are, like majority sample at 1 and you can predict that right, and then everything else will be okay?
So our data set that we used, the majority were actually offensive language, and there wasn't much on hate speech, as hate speech was like specifically like racial slurs.
Sorry,
So
like zero is hate speech.
yeah, sorry, yeah. So 0 is hate
And
speech.
1 is offensive.
1 is offensive, yes.
And 2 is neither.
Yes.
Okay, so what I'm saying is, if you have one class that's, overwhelmingly, the population, then your model can just always predict that, just always predict 1, and you would have a very good accuracy, right?
Yeah, so that was the biggest issue we had with our model, was that since like a large portion of our data was actually the offensive language, we had issues where the model had difficulties predicting between offensive language and hate speech. So yeah, that was the biggest issue we had.
So how can we mitigate that?
So what we were thinking was simply the best one would be adding more hate speech data. And then another one would be just straight up combining hate speech and offensive language into one and making a binary classification. So then, especially because logistic regression works better as a binary classification.
You can also downsample, maybe, like 0 and 1 category together, right? Because you don't need that many, maybe. The neither one has like, nearly like more than 1,000, right? So you can just downsample, the 0 and 1, combine them together, and then your data set will be balanced.
I think that's what Tabito said.
Say it again.
I think that's what Tabito just mentioned.
Got it.
So my name is Tanaya. I made the website, which is essentially the web development, and I also helped out with the HTML.
Tanaya also worked on the sites. For me, I worked on the pre-processing.
Hi, I'm Tabito, and I worked on the machine learning models.
And Ralph also helped out with the web development. And I'm Nimi, and I also helped out with the data pre-processing and one of the models. And Fernanda was our wonderful mentor, so thank you, Fernanda. And thank you all for listening, and let us know if you have any questions.